Okay, write the ratios for sine of x and cosine of x. And you should remember, so katoa, so sine is opposite over hypotenuse. Cosine, is adjacent over hypotenuse. And toa is opposite, tangent is opposite over adjacent. Okay, so when they want to know what the sine is of x, we are doing the opposite over the hypotenuse. And then we'll do the cosine, which is adjacent over the hypotenuse. But which one are we doing it from? We're doing it from this one. Okay, so first, let's do the sine. What is the opposite side from x? Well, that's the opposite side right there. So we should have, for sine of x, we should have root 119 on the top. And what's the hypotenuse? The hypotenuse is the hypotenuse across from the 90-degree angle over 12. Then we're going to do it again for cosine x. Let me erase these marks. Okay, cosine is the adjacent over the hypotenuse. And what is the adjacent side for this x? Well, it seems like there's two adjacent sides there and there, right next to, but we never call the hypotenuse the adjacent side. It's always called the hypotenuse, and that leaves that 5 to be the adjacent side. And what's the hypotenuse? The hypotenuse is 12. So we're looking for the answer where they have sine of x is root 119 over 12, that's C, and cosine x is 5 over 12, that's C. That's our answer. Got a few more of these to do. So here's the next one. And the tangent ratio for angle y and angle z. So we need tangent of angle y. Let's start here and say if we were at that one, tangent, remember TOA, tangent of y is opposite over adjacent, which is, what is opposite of angle y? 7. What is adjacent to angle y? 4. So that's what you should get. You should get tangent of y is 7 over 4. So it's looking already good for A. Now let's do it again for tangent of z, because I want tangent for both of these. Tangent of z, also opposite over adjacent, but those are going to be different sides when we're standing at z. So here we're at z. Opposite is what? Opposite is 4. Adjacent is what? 7. And so tangent of z is 4 over 7. And you'll notice, so again, that's answer A. You'll notice that the tangent of one angle is the reciprocal of the tangent of the other. I'm interested if you can figure out why that is and why that's always going to be the case. Anyway, we've got 2 more to do. And the next one is 22. I want the tangent ratio for P. And how do we write that? We can say tangent of P is equal to, for P here, opposite side over adjacent side. Opposite is 16 over the adjacent side, 12. And then if they wanted the tangent of Q, and they do, then what's opposite of Q? Opposite is 12 over the adjacent side, which is 16. And as I just said on the last slide, that's what's going to happen. The tangent of one angle is the reciprocal of the tangent of the other angle. So tangent of P is 16 over 12. Tangent of Q is 12 over 16. And that corresponds with C. One more to go. Okay, we're writing the sine and cosine ratios for A. So from A, we've got sine of A, sine, so opposite over hypotenuse. Opposite is 24 over hypotenuse is 26. Cosine of A, adjacent over hypotenuse, the adjacent side for A is 10, and the hypotenuse remains 26. So we've got sine of A is 24 over 26, cosine of A is 10 over 26, and that is C. You can see that you could actually simplify those ratios, but they're still equal. So if they weren't simplified, it's still true. So you don't have to worry about that part of it. If they offer it to you as a non-simplified, non-reduced fraction written in simplest terms, then that's fine. Just pick the answer that's equivalent.